Hi guys, so today we're looking at the 2017 exam question 12C. This is based on concave mirrors. It is challenge 4 in your notes. It has recently been suggested that the 17th century Dutch artist Rembrandt used a concave mirror to help him etch self-portraits by projecting an inverted image onto a copper sheet. So we're asked to draw a ray diagram of how he used a concave mirror in this way. So we're told that the image produced is an inverted image. An inverted image, if we go back in our notes, we can see that an inverted image is produced in a concave mirror when the object is placed outside the focal length. Okay, so that is our tip of what type of ray diagram we're drawing. We want an inverted image, so therefore our object must be placed outside the focal length. Okay, so we're going to draw in our concave mirror and place the focal length before and after the mirror. These should be equal distance from the pole. And then we're going to draw our object. Okay, so here's my object. I'm going to label that object. So rays are coming off the object and I want to see where the image is formed. To find where the image is formed, I look for the intersection of light rays. We know that a ray that travels parallel to the principal axis reflects through the focal point. So this is our first ray. We also know that a ray that travels through the pole has an equal angle of reflection from the principal axis. Where these rays intersect is where the image is formed. We can see that this image is inverted as it is below the principal axis. Okay, so that's part 1 done. Let's look at part 2. Part 2 states, Rembrandt used a concave mirror to measure a focal length of a concave mirror of focal length 60 centimeters so that the image on the copper sheet was only half the size of the object. Find the distance from the sheet to the mirror. Okay, so we want the distance from the sheet to the mirror. So the first thing I'm doing is underlining the values that I'm given. And above these values, I'm going to write down what letter they represent. Okay, so F is the focal length. We're told that the image is half the size of the object. So that's the magnitude. So the magnitude is a half. And we're looking for V. We're looking for the distance that the sheet is to the mirror. So the image is formed in the sheet, therefore we're looking for V, that distance. Okay. Let's write down what we know. So we know the focal length is 60 centimeters. I'm looking for V, and I'm told the magnitude is equal to 1/2. The first thing I do is write down my formula for the thin lens. 1/f is equal to 1/u plus 1/v. I know I'm looking for v, so I can use this formula to find it. 1/60 is equal to 1/u plus 1/v. I'm looking for v, but you should see that in this formula we have a second unknown value. So we use our second piece of information to write u in terms of v. We're told that the magnitude is equal to a half. Our formula for our magnitude is v divided by u. This means that 1/2 is equal to v divided by u. Cross multiplying, I have u is equal to 2 times v. I can now substitute this into my thin lens formula. To solve for my V value, my distance from the image to the pole. Okay, so substituting this in, I have 1 over 60 is equal to 1 over, instead of u, I now know that u is equal to 2v, plus 1 over v. Okay, so I want to solve for v here. The first thing I'm going to do is simplify my fraction on the right-hand side, i.e. write this value as one fraction. To do this, we need to find our lowest common multiple, or lowest common denominator. So we multiply our two bottoms together and we cross multiply to find our new top. Our lowest common denominator in this case is 2v. 2v divided by 2v gives you 1, and v divided by 2v gives you 2, times our numerator of 1. I'm left with 1 over 60 is equal to 1 plus 2 over 2v. From here we'll simplify. 1 over 60 is equal to 3 over 2v. To solve for v, we're going to cross multiply. 2v times 1 gives you 2v, which is equal to 3 times 60. This leaves me with 2v is equal to 180. To find v, I divide both sides by 2. And v is equal to 90 centimeters. So my distance that my image is from the mirror is 90 centimeters. Okay, so just leaving that on the screen for you. Okay, let's look at part 2. Part 2 asks to find the distance from the object to the mirror. So in this case, we're looking for u, the distance from the object to the mirror. Okay, so let's scroll over to see what we know. So in this case, we're looking for u. What do we know at this point? We know that m is equal to 1/2, the magnitude is equal to 1/2. I know my focal length is equal to 60. And I've also found my distance from my image to the mirror as 90 centimeters. And we want to find u. So what two formulas do I have that have u in it? Well, I know that 1 over f is equal to 1 over u plus 1 over v. And I know that my magnification is equal to v divided by u. Because I have f and I have v and I have m, my magnitude, I can use either of these equations to solve for u. I'm going to use the second one. Substituting in what I know, my magnification is equal to 1/2. So 1/2 is equal to 90 divided by u. And to solve for u, I cross multiply. U times 1 gives me u, which is equal to 2 times 90. U is equal to 180 centimeters. Okay. The final part of this question states that a concave mirror can be used to produce an upright image. Explain why this image is not of use to Rembrandt. An upright image is formed when we produce a virtual image on the screen. This is formed when the object is placed inside the focal length. Because an upright image is only formed by a virtual image, Rembrandt could not use this image as no image would be formed on his sheet.